I'm here with Boaz. He's the CTO and co-founder of Tactile Mobility. Boaz, you guys have built a software solution that is taking information from sensors inside of the car about the road quality, possible hazards inside the road, and that has a number of different applications. Tell us a little bit more.
Great. So when you look at the smart vehicles today or the autonomous vehicles in the near future, we would like to replace the driver. And first of all, we'd like to replace the driver's sensors. And our main sensor, of course, is the eyes. Okay, so you have a lot of visual sensors you can see here, tons of them, like lidars, radars, cameras, ultra-red, whatever. Okay, so but they're all pixels. But if you try to think about yourself driving a car remotely with visual only, it will be difficult. Okay. Yeah. So you need to feel the road, you need to feel the surface, and you need to feel the interconnection between them. Like what my road, my tires, my weight now will do with this specific surface attributes. So what we do is that we collect the information existing today in the sensors in the car for today's cars, like wheel speed, throttle position, engine torque, wheel torque, etc. Then we fuse it, we do some machine learning on top of that. And then we derive real-time insights and feed them back into the car, like for preconditioning. So for example, we learn a lot about the surface DNA, as we call that, and fuse it with the vehicle DNA. So both surface DNA and vehicle DNA provides you what you can do there. For example, do we have a slippery road? What will be the maximal excitation I can apply there, like braking, steering, etc.? What is the current road grade, inclination, banking, etc.? Any hazards on the road, like small potholes, cracks, etc., that can influence my drive, my safety, my enjoyability, and efficiency of the driving. So a camera may see like a bump in front of you, but what's the nature of the bump? How fast can my car drive on top of it safely, enjoyability? So that's what we do. On top of that, besides this valuable information fed back into the car network, we send it out to the cloud. Then we normalize it so we can share all the crowd information and build a tactile map of the world, a refreshed tactile map. So today we're working with OEMs to place our software, no hardware, so software only inside the ECU, collecting this data, generating this meaningful information in the cloud, providing you a free, fresh data around the world. So that's what we do.
Very cool. And you also have an application for anybody managing a fleet would be interested in using this platform, as well as mapping, as you said, is core to this, meaning that you have all these data points from every car on the road that has your technology installed in it. You're updating your maps in real time.
Yes, exactly. I mean, think of the tactile virtual sensor as something unique in the car, okay, that doesn't exist so far. And now think of the first person who introduced a camera to the car as a sensor. Now they're asking, what can you do with that? Say, okay, you can point it outside and see any hazards in front of us. You can point it inside and see if the driver is asleep. You can point it upwards, see if the skies are nice and clean and shining. So a lot of things you can do with the visual sensor. Same for the tactile. So today we have a lot of applications we can do on top of that. So we can enhance safety on the road in real time. So for example, what is the distance the car should keep for adaptive cruise control in front with the car in front of me? What is the maximum safe speed to take the next exit? What is the steering parameters to control in order to make it safely steer over black ice that you can't see it with the camera, for example. So this is part of the applications we can do in real time in the car. In the cloud, when we have the data, we can provide it to municipalities for road maintenance, for prioritizing road maintenance, for hazard detection in real time. Then for fleets, we are talking about, for example, with large commercial fleets like a rental car, big rental cars, where they have a problem of unclaimed damage. I mean, you return to the car at the airport, no scratches visually outside, it's fine, but who knows how did you drive the car? Did you do some abrupt braking with your tires, okay? Like drifting with your tires, maybe your tires are worn up.
All right, you're doing donuts in the parking lot.
Exactly. So we detect that.
Boaz, my question is, just to wrap it up, where is Tactile Mobility in terms of your funding business journey, and what's next?
Okay, so as you all know, I mean, it's a long journey with the car makers. Years. It takes years to get into production line. We are 7 years, actually, literally on the road. 7 years, and we have like 2 years in front of us for commercially availability in production line. So today we are finalizing commercial agreements with the leading OEMs around the world. That's for 3 of them, the main of them. And then on top of that, we are now fundraising currently with major names in the world with the money that will keep us a runway forward till we get into production line. So basically, my vision as the Tactile Mobility founder and the CEO of the company is to have the tactile leading map of the world in real time, to be the Google of the tactile service.
Very cool. Boaz, thank you so much. It's Tactile Mobility, gathering sensor data from all parts of the car to create a real map, a more accurate map of the road conditions all around the world. Thank you.